why do we rotate crops?
To reduce pest buildup.
To reduce pest pressure or disease pressure. And why do we have pest pressure or disease pressure? This is the conventional rationale goes? Because the crops have pulled those minerals out.
Right.
So corn's a heavy feeder, or broccoli's a heavy feeder, so it's pulling everything out of that soil, so we don't want to put broccoli back in there until 3 years from now, when it's going to heavily feed again. And we do that a few cycles, and you've heavily fed everything out of the soil. And the solution to that problem is to move your plants away, not to feed the soil what has been fed out of it. It doesn't make much sense to me, really. I think honestly, if you look at nature, polycultures are the way nature does things, and so big monocultures are not the way nature does things. So I don't know. I mean, there's interplanting. People refer to interplanting. You've heard of companion planting. Getting as many different windrows and untilled areas. Even if you got a pathway, a pathway every 4 feet that's growing something, that is a polyculture functionally for the soil. So we have this idea of clean fields, bare fields, straight lines. That I don't think is an environment where nature's going to flourish. So I think I made that point. If you're gonna rotate your crops, that's fine with me. I think the issue is still to feed back into the soil that which has been taken out. So things like boron, things like sulfur. I mean, I can just about guarantee if you haven't added those things to your soil, you're categorically deficient around here. There's a bunch of other ones. Manganese, very high possibility. Cobalt, very high possibility. Molybdenum, high possibility. I don't know where the calcium is and where it's not. In many cases, people have low pHs, have really low calcium levels in their soil. There's a lot of critical elements that are necessary for a plant to grow that are not present in your soil. So only when you put those things back in your soil should you expect your plant to have what it needs to be resistant to pests and diseases, which is the rationale for rotations. So let's talk about that for a second. Biochemistry, plant biochemistry. The idea here is that the plant makes sugar, injects it down into the soil to feed the soil life. I think there's supposed to be about 4.5 million species of soil life, and this is, of course, we're just taking a number and throwing it to the wall, right? Because we've named about 5% of them. Doesn't mean we've studied 5% of them, it means we've named 5% of them, right? Which means only 95% of them haven't been named yet, which means we have really no idea about how many different species there are. But we'll say there's 4.5 million different species, and some are bacteria and some are fungi, etc. And each of these different species has a different functional capacity. Cows can do certain things, rabbits can do certain things, So the plant will take sugar and attach this amino acid to it to make it food for the bacillus, and it'll attach that protein to it to make it food for the mycorrhizal fungi. However it works, the plant knows which species are good at doing which jobs. Some species are good at solubilizing calcium. Some species are good at solubilizing potassium or copper or zinc or phosphorus. And so when the plant needs phosphorus, it takes sugar, makes it food for phosphorus solubilizers, and injects it into the soil. And this is a much more intelligent feedback system than conventional agronomy, which is take your NPK, pop it on in the spring, maybe it's slow release, so it'll be available through the season. You got 3 elements, and they're in a soluble form already, so the soil life is not needed to digest them. I like to call this the IV drip method. So you can take an IV drip of saline solution, inject it into your arm, and not eat, and stay alive. In many cases, you're likely to get infected with other things while you're under this process, but it can be done. But that short circuits the whole digestive system. Conventional agronomy has that as its principle. So something they have a number, NPK. If it has a number, it means it's soluble. It means it's like an IV drip. So you really want amendments for fertilizer, which you can't call it fertilizer. It's only fertilizer if it has a number, right? So that's why I use the word amendment, because we're talking about things we're amending to the soil. We're not fertilizing the soil, we're amending the soil. Anyway, semantics. But you can't use the word fertilizer if there's no number on it. So rock dust, as an example, may have 35 different elements in it, but it'll have a fertilizer number of 000. Nothing soluble. We don't want it soluble when you put it down. You want it soluble when the plant wants it soluble. And the way the plant determines I want copper today and I want zinc tomorrow is based on what it needs to build its body.